In my previous video, we implemented the domain layer of the Football League application using the clean architecture and the domain-driven design. Today, I'm going to implement the application layer of the clean architecture using the CQRS pattern and the Mediatr library. We will build commands, queries, and handlers and cover both data reading and writing use cases. Please note that we will build the same Football League application we started in the previous video. So if you want to learn how to build this application from scratch, please watch my previous two videos. Let's get started. So what exactly is the CQRS? It stands for Command Query Responsibility Segregation, and it's a powerful pattern that splits your application actions into two separate paths, commands and queries. As you can see here that the APIs are either following the path of the command or the path of the query to communicate with the database. Let's cover some of the key differences between the commands and the queries. Commands are usually the operations that modify the system state. Commands usually do not return any data. Commands are normally seen as actions or intentions. Example of commands can be creating a user or adding a product in a shopping basket. Queries, on the other hand, are operations that do not change the system states, means there are no side effects of running the queries. Queries are normally the operations that return data. Queries are designed to efficiently return the information to the user or the caller. Example of queries can be viewing a user profile or fetching a list of products from the database. The first principle is the separation of command and the query models. CQRS distinctly separates the operations that change the system state from those that retrieve data. Means the commands and the queries usually follow the separate logical path. By separating the reads and the writes, each path can be scaled and optimized independently. This is very useful for read-heavy systems where ratio of reading the data is higher than writing the data. This separation also allows us to use different data stores for commands and the queries. For example, a system can use a separate database for commands that is specially optimized for writing the data, and can also use a separate database for queries which is optimized for reading the data. CQRS promotes the separation of concern that allow us to focus on different requirements for each path. For our queries, the flow could be relatively simple. We want minimum steps or interactions to maximize the performance of our queries. Here you can see the query handler is using the Dapper library to directly execute the SQL queries in the database so that we can return the data with maximum performance and efficiency. For our commands, the flow is significantly more complex because first we need to fetch the entity from the database, and then we need to execute the business logic by often relying on the domain-driven design or rich domain models. And finally, we need to save the changes in the database using either the repositories or unit of work. The first thing we need is to create custom abstractions for our commands and queries, which are essentially the contracts of our message. So let's create a folder in the application project and call it abstractions. The first thing I'm going to create is a custom abstraction of the command, and that is going to be a marker interface for all the commands. It's going to be public. You can either create a command of your own, or you can also use a Mediatr library to create your commands. In this example, I'm using a Mediatr library. So let's implement the Mediatr library iRequest interface on top of your command. The commands that will implement this iCommand interface can perform the operations, but they cannot return any data to the caller. Let's say you also have commands in your project that return some sort of data to the caller. For example, sometime we need to return the ID of the newly created entity to the caller. You can also create another command interface. You can specify what this command interface will return. In this case, I'm using the generic T-response that will specify the type of object I want to return from this command. Just like commands, we also need an abstraction of queries. So let's create another marker interface, iQuery. This query class will also be public. You can specify the T-response as the generic type of response, and you can implement the same iRequest interface available in the Mediatr library. Now that we have the commands and the queries abstractions ready, we also need the abstractions for related commands and the query handlers. Let's create a new file in the abstractions folder and call it iCommand handler. This interface is also going to be a generic interface, and it will specify the type of commands we can pass inside. And here we need to specify a generic command object. This interface is going to implement the iRequest handle interface available in the Mediatr library. I can also specify the type of commands it will handle. In this case, I'm specifying that the commands this handler can handle should implement the iCommand interface we already created. Similarly, we also need a command handler for the commands that returns response. So let's copy the same command handler, and this time I will also specify a generic response this command will return. Next, we need to create a base interface for all our query handlers. Let's call it iQuery handler. This is also going to be a public interface. This interface is similar to the iCommand handler, but this will handle our queries, not the command. So let's declare a generic tQuery, and for the response, we can specify a generic tResponse. This interface will also implement the iRequest handler interface available in the Mediatr library. And just like the commands, we can also specify that the tQuery will be a query that is implementing the iQuery interface. Now that we have all the abstract messages available, it's time to create some of the use cases of the application. My personal preference is to create a features folder in the application layer to combine all the use cases related to one feature inside one folder. So let's say in our Football League application, we need features related to clubs, players, stadiums, matches, etc. So I'm creating a features folder for clubs. Similarly, I can also create a features folder for players, and also I can create a features folder for stadiums. Let's say one of the use case in the Football League application is to return the list of all the clubs available in the league. Since we are returning a data and not updating anything in the database, so it should be a query. I'm going to create a folder for my first use case, and folder name should be related to the use case. In our case, it's get all clubs. Inside this use case folder, we can create our first query, get all clubs query. This class is going to be public because we need to call it from the API layer. As my personal preference, I use C# brackets for commands and the queries because they are immutable by design. We already implemented the abstract marker interfaces for the queries and the commands. As this is the query, so let's implement that iQuery interface on top of it. At this point, I need to decide what information about the club I want to expose from this query. So let's create a DTO class, and I'm calling it getAllClubsDTO. This class will also be C# bracket, and you can use the primary constructor to quickly create the properties of the DTO. In this case, let's say we want to return the club ID, club name, club photo URL, and the club website URL. So let's define those properties here one by one. Second property will be the name. Then we need photo URL. And finally, let's say we also want to return the website URL of the club. Now we can return the list of our DTOs from this query. The next thing we need is the command handler related to this query. So let's create a new class and call it getAllClubsQueryHandler. This query handler will implement the iQueryHandler marker interface we already implemented. And for the query, you can pass getAllClubsQuery as a first parameter here. And for the response, you can specify a list of getAllClubsDTO objects. Now we need to implement the handle method where we can define all our use case logic. Here inside this handle method, we have two options to return the list of clubs. We can either use the entity framework, or we can use a library called Dapper that can execute the raw SQL queries directly in the database. To execute the queries using the Dapper library, we need some sort of open connection from the database. So let's create an abstract interface in the application layer that will manage the database connections for us. I'm going to call it iSQL Connection Factory. Let's make it public interface. First method I'm going to declare is a getOpenConnection, and that method will return me IDB connection object. The second method I'm going to create is a createNewConnection. Finally, I'm going to declare a getConnectionString method that can return me the database connection string. Now we can inject this iSQL Connection Factory interface in our handler using the primary constructor. Inside this handle method, we first need to create our SQL query. I'm going to create a simple SQL select statement that will return me the club ID, club name, club photo URL, website URL, and we can sort our clubs by name. Next, I'm creating a connection variable that will hold the open connection to my database. To create an open connection, I can use the SQL connection factory dot get open connection method. I can also use the using keyword so that my connection object is automatically disposed of. Finally, using this open connection, I can use one of the method available in the Dapper library to execute my queries. As we are returning the list of clubs, so we need the query async method. Here we can specify our DT object. Inside the method parameter, the first parameter will be our SQL query and second parameter will be the cancellation token. As we want to return the list of our DT objects, so here we can use the await statement and we can use the asList method available in the Dapper library. I also need to make sure this method is async. Let's implement another use case in the clubs folder. And in this use case, let's say we want to return a details of one club. I'm going to name it get club details. The first class I'm going to create is get club details DTO. This class will be a C# bracket and it will specify the list of properties we want to return for a single club. So let's say I want to return the club ID, club name, club photo URL, and club website URL. Next, I'm creating a get club details query. This query will accept one parameter that will be the club ID, and it will also implement the same iQuery interface, and it will return a single get club details DTO object. Next, I'm going to create an associated query handler for this query. I'm going to implement the same iQuery handler interface. And here in the first parameter, I can define the get club details query. And I can specify the response object as get club details DTO. Just like the previous handler here, once again, I need to inject the iSQL connection factory interface. The implementation of this handle method will be similar to the previous handle method we implemented. So let's copy all the code from the previous handler and paste inside this handle. The first thing we need to change in our SQL query is to replace this order by clause with the where clause so that we can filter the club by ID. Next, we need to remove this asList method because we are not returning the list of clubs this time. We also need to change this DT object. Next, we need to replace this query async method with query single async method because this time we are returning a single object. And finally, we need to replace this club ID parameter in the query with the actual value. And you can pass the club ID parameter as a second parameter of the query single async method. I think now you have an idea how to execute the queries in the database using the CQRS and the Dapper library. Let's say we have another use case in our application in which we want to update the clubs in the database. Since this use case is related to updating the database, so we need a command, not a query. Let's create another use case folder and I'm going to call it update club. Inside the update club folder, we need to create our command. I'm going to call it update club command. Just like the queries, the commands will also be C# brackets. We can once again use the primary constructor to define the parameters this command will receive. So let's say for this command, I want to pass the club ID, club name, club photo URL, club website URL, and the last parameter will be updated by that will specify the user ID updating the club. And this command object need to implement the iCommand interface we declared earlier. Next, I'm going to create an update club command handler. This class will implement the iCommand handler interface, and inside here I can pass the update club command. Next, we can implement this interface and define the logic inside this handle method. Inside this club handler, we can inject the iClub repository available in the domain layer of this project. The first thing we need is to fetch the club entity from the database using the club repository. We can use the getById async method, and here we can pass club ID as a parameter. Now we can use the update method available in the club entity to update the club. This method is accepting the name, photo URL, website URL, and the updated by as a parameters. Let's pass these parameters one by one. And finally, we can use the commit async method available in the club repository to save our changes in the database. Another thing you can notice is that our query handlers are using the Dapper library and executing the raw SQL queries directly in the database. And commands are designed to go through our full domain model like repositories or ORM like Entity Framework code. Another thing you need to notice is that I'm not adding any exception handling code or validation logic inside this command handler. If you want to learn how to validate these commands, you can watch my video on the Fluent Validation Library. If you like this video, smash the like button and also subscribe to my channel for more software architecture videos. In my next video, I'm going to implement the infrastructure and the persistence layer of this application. Until next time, stay awesome.